welcome back to the shop. So I have decided to build a new CNC machine dedicated to making my my branding irons out of brass. So I showed you guys a while ago a rendering of the machine I've designed. So I keep throwing that footage out there, but here it is again, just so you can refresh your memory. It's nothing super complicated. Moving table design with a gantry that goes left to right and a table goes forward and backwards. So the theory on this is to split up the inertia so that I'm not shoving a 95-pound gantry around to cut a little 1-inch diameter space. You know, it doesn't make a lot of sense to have that much machine for such a small part. So I'm downsizing to a dedicated machine that will have about 6 inches of travel in both directions. What that'll get me, it'll be a little over 6 inches. What that'll get me is enough room to cut up to 5 2-inch irons at one time. I don't typically see more than, like, there have been some nights where I've done like 8 in a single day, but you know, it's not, I think a production run of up to 5 is a pretty good amount of scaling. And the big reason for doing that is so I have fewer cutter changes. Like the only real time-consuming spot on machining these is there's a roughing phase and there's a finishing phase, and they use a different cutter. So it has to do the roughing, then stop, change the cutter, put in the V-bit to do the finishing passes. What that usually means, if you do 5 irons, you got to cutter change 10 times. But if you do 5 at once, you've only got 2 cutter changes. It's pretty small. So it would save a little. It saves a little time, and it also saves a little babysitting. Like I can do the whole flattening and roughing phase on 5 different irons, no problem, pretty quickly. Yeah. So that's kind of the plan. You saw the machine basically. We are now in the point where I've got a decent little window to get this thing going. So what I'm going to do is real quickly I'm going to show you some footage I'll be shooting. I haven't shot it yet, but what the first thing I'll do is I'll go through from the design. Now I've got a design that I've drawn up in Sketchup, and now I need to get it into the CNC machine. So I figured I would capture that for you. So I'm gonna jump to some footage of that process of getting it from SketchUp into getting the design from SketchUp and turning it into parts that are using G-code to be cut by this machine. So this little guy is going to be building its own, helping me build its own replacement for this task. The whole idea is I have a 60 by 30, 28.5 machining envelope, and the biggest thing I've cut so far has been 3 inches in diameter right in the center. It seems kind of silly to be tying up a bigger machine for such small work when the little machine can be doing that. That'll free me up to do some adjustments to this machine once the little machine's done. Then I can tear this thing down and do a few little tune-up things, make a few adjustments, and get it into, you know, it's got a couple thousand hours on it now since I built it. So, you know, it needs a little TLC. So that's what I figure I'll do after this machine's done. So here's some footage to take it from SketchUp parts or SketchUp assemblies into CNC machinable parts. Okay, so we're in SketchUp, we're looking at our design, and the point of this is to kind of get a process, or to show the process that I'm going through to go from this assembly to specific parts getting machined. So the biggest thing for me is when I work on really complicated mechanical type things or large assembly type stuff, like, I don't know if I say large, but just assemblies that need, you know, I need to make sure parts will clear each other. I often design in SketchUp first. So things that are, you know, like especially moving parts, I tend to do this. So I tend to design in SketchUp the most, because at least for assemblies, because it makes life a lot, I don't know, it allows me to visualize how things will fit together. So alright, so the first thing I'll get is isolate all the pieces that I'm going to turn into parts. Not all of this is going on the CNC. In fact, only the flat plates. So I have put all of those parts, like this and the sides, and this plate for the mount, and this mount here. I've put all those on this CNC plates layer. So I'm going to switch to that. I'm going to turn everything else off. So these are the parts we're going to make. So all of these pieces have been sort of thought through to the point of where every hole needs to be, except for, I'm going to turn this back on real quick, the linear rails have slightly irregular spacing. Like the hole spacing in the base isn't exactly where I'm not sure I can trust the spacing from one rail to the next. They're pretty close, but I want to do those as a separate process. So I did not include them in the model. So you can see there's no holes for the linear rails for this on this or here. So the rest of this is just the holes for everything else. And so my plan will be that on my machine, my current machine is to cut these parts out, but I can't rely on that machine. It's not quite rigid enough for really doing aluminum. I'm kind of making it do more than it's sort of designed for, so I'm kind of going to baby that machine a little bit. And rather than do any of the holes, because a lot of these holes have to be very specific sizes for drilling and tapping for threads or for other uses, I should say. And I'm going to do a few other little things that I discovered in the cam later when I went to machine these parts. But we'll get to that in a second. So first part is I got all those parts isolated on this layer. Okay, so the next bit is just from an organizational standpoint. I'm going to take each of these parts and save them out as separate files. So basically I'm just going to copy it with Control-C. I'm going to create a new file. I'm going to paste. And it's kind of just going to set it wherever the heck it wants. So go vertical, and there we go. That's our part. We're going to save it into my CNC plates, and I've already done this one left. I'm going to name this a frame left demo. And now that's saved, we go back to our original file to here, and we do the next part. And we just keep doing this. Control-C, Control-New, do the same thing. So once we've got all these parts saved as separate files, we can then get ready to move into CAM. CAM is going to turn these things into tool paths that will cut on the machine. So let's switch over to CAM now, and I'll show you that process. Alright, so we're in our CAM software now, or it's sort of CAD CAM. I'm using Vectrix Aspire. This will also work just fine with Cut2D and VCarve Pro because all we're doing are 2D toolpaths. So we're going to start camming up the first part that we're going to cut on my machine. It's going to be one of the stepper mounts because it's one of the easier pieces to make, and I have a lot of scrap, or I have a lot of extra material. So I have a lot of extra raw materials to start with that if I mess up, I can start again. The big thing is, part of this is learning what my current machine can handle when it comes to machining aluminum. So we're going to be gentle with that machine and make sure that we don't overdo it or push it too hard. So we're going to start with one of the stepper mount pieces, and those are all going to get cut from a small piece of 1/4-inch aluminum that I have. So we're going to create a new file. It's 4.5 by 5 and 1/4 of an inch thick. And we're going to set our XY datum to the lower left corner. Normally I run from the center, but on these parts, because they're one-offs and they're kind of irregular pieces, some of them are bandsaw cut, all sorts of stuff, and they cut, the parts are very tightly controlled. The pieces are very tight within the work pieces, so these parts are going to have very little waste. In some areas we're going to be cutting out the very edge of the part, of the workpiece. So we're going to go lower left corner, and I'm going to say OK to that. And the big reason on that is I'm going to be machining a spoil board out of 3/4-inch MDF that will have a pocket on the left side. There'll be a ridge that I'll reference against. The idea is, because the tolerances, or because the parts are so tight a lot of the parts are so tight. These particular stepper mounts aren't. These are one of the few that have a fair bit of extra room. But because most of the other parts are so tight, I want to make sure that they get aligned on the machine with with one of the axes. And in this case, I'm going to use the left edge to be aligned with the Y axis. That way, all the parts can butt up against a ridge, or some sort of, maybe I'll cut some sort of locating pins or something like that. But I have a feeling the ridge will work just fine. And then I can hold it down to that spoil board, and I can cut through without worrying. But there's a step-by-step process here, so to get the part to cut out safely, and it's not the fastest, I'll tell you that now. It's kind of me limping along with the machine that I have, because it can't plunge very well for drilling any holes, so we're not going to drill any small holes that will be used for fasteners or anything like that. All those holes will be cut later, usually just drilled on the drill press, and some of them will be tapped. But because my machine doesn't plunge into aluminum terribly well, I have to be careful about that. Alright, so let's get started with the import of the vectors. Okay, so we have our part defined, or our workpiece defined. We're going to import the vectors. So first thing we'll do is we'll import our stepper mount YZ. This will be the sort of T-shaped part. So you'll see this here. We're going to bring it in. Since we're doing very simple 2D tool pathing and we're not breaking outside of the outer edge of the boundary, like we don't have dados or grooves or anything to machine, all these default settings should be fine. We don't really care about this replace outer boundary. None of this grouping thing really matters to us. We definitely want to make sure we create circles and arcs when we need to, because SketchUp doesn't save these things as circles or arcs. They're just straight line segment geometry. This will detect it and create them as circles. And say OK. Alright, so we've imported our SketchUp file, and it kind of oriented it. I was hoping that it would orient it the way I'd like, but we're going to take a second and switch this a little bit. We're going to rotate it 90. We might do this a couple of times. Yeah, we're going to flip it like that. Okay, and then I'm going to center this in this workpiece. And so this workpiece is going to butt up against the edge of my locating, and then I'm going to screw it down. So I need some room, around the outside edges to at least hold the part down. I want to make sure things are where they belong, and so that this workpiece doesn't come off the machine. So one thing is I'd like to avoid having the workpiece come up. Okay, that's a good thing. And the other piece, as I alluded to this earlier, is that my machine does not drill holes very well. In aluminum, it just doesn't like to plunge. There's a lot of slop in the plunging. This is normally never a problem in wood, but in metals, you can't plunge safely enough with an end mill to do this hole. And I don't have enough collets for the actual sized drills, and I can't spin the machine slow enough. The spindle doesn't spin slow enough for most of the drilling that I would need to do anyway. So, foregoing all of that, what I'm going to do is wherever there's going to be a hole that I can't machine with the CNC, is I'm going to use a V-carving bit and mark the center points of all those holes. So let's get that toolpath set up. So the first thing I'm going to need to do is ungroup this object, because whenever you import from SketchUp, it groups everything. I think there might be a checkbox for that. Doesn't really matter. It doesn't take long. And if you're using version 9 from Aspire, there's a really handy thing. For these slots, I'm actually going to cut those on my manual milling machine, but I need to use them. I'm going to use, one of the things I'll do is I'll mark all these holes, and as part of the work holding process, I'm going to drill a couple of them and screw them down to the spoil board on the machine so that I can cut the outer profile and have it completely free the part without the part flying around. So I'm going to fasten the parts down. And we're going to go through a couple of evolutions of this. Depending on the part, depending on how big the workpiece is, depending on where the holes happen to be, and you'll go through, as I go through each part, you'll see the different slight challenges. It's all basically the same, but there'll be nuances to each one. So the first thing I need to do is I want to put a little tick mark with a V-bit in the center of these two holes, but I can't do them as the slots. They have to be circles in order for the drilling toolpath to catch that. You'll see that in a minute. So the first thing I'm going to do is draw a couple of helpful vectors. And if you're using version 9, you'll see some new snap options, and they're really handy in this case. And so we're just going to make some 1/4 inch diameter vectors. I'm actually not going to make 1/4 inch diameter holes. I just need to get a center point in each of these places. Okay, so now we've got those. We're going to select each of them. If I can click properly, we're going to just select all of our holes, and you can do some fancy dragging to click. Oop. Hold on, let's do this. You can do some fancy dragging, and then unselect that one, and then select that one, and select that one. So these are all the circles that I want to poke little center divots in. So we'll get that toolpath going next. Okay, so we've selected our circles that we're going to put holes in. We're going to choose the drilling toolpath as we will use that because it's actually really handy because it pokes right in the center. And instead of a drill bit or an end mill, we're going to use a 90-degree V-bit. That's all we're going to use. And we're going to have it go only 10 thou deep. So I'm going to play with this a bit on the machine. You're going to see, you'll see me, I'm trying to plan as much as I can, but I have a lot of unknowns as far as what my machine can handle or what will work as far as getting things zeroed properly and just, you know, making sure everything's nice and flat and smooth and get these parts where they need to go. We're going to start with a cut depth of 10 thou. We might adjust that, or I might just run the toolpath more than once, just have it run with the Z0 moved a little bit. So we might just tweak that as we go. And then that'll cover this. We're just going to say we're going to name this toolpath holes. I'm going to calculate that. Okay, so now you see there's this little tick mark in the middle of each of the circles. Those are basically like center point punches, like if you used a center punch. And that'll be where I can guide my drill. When those are cut, I'll drill a couple of holes and I'll mount screws in them in a couple of these areas so that it holds this main workpiece down. The next step will be to cut the stepper hole. Okay, to cut a hole for the stepper, all the steppers have these little flanged things, this little step that goes into this sized hole. So we're going to take that vector and I'm going to do a profile toolpath. And now this one is the first cut that we're going to see how well we can get a good edge finish on my machine with. And so what I've decided to use is a 1/2 inch roughing end mill, and it's because it's got two flutes that are really deep, that are nice and smoothly curved on the inside. The gullets, the flute geometry is such that it should help eject the chips nicely. The biggest thing with cutting aluminum is chip clearance, because you'll oftentimes have so much heat built up that it will melt the aluminum to the tool, and then it recuts and it gets the surface finish gets terrible. So we're going to do a few things to mitigate that. One is this larger tool with a fairly slow feed rate. I'm going to play with these things too to see how much the machine can take. I'm starting very conservatively. I'm pretty sure it can handle a 20 inch per minute feed rate. And we're also going to do some things that'll slow that down a bit based on the plunge rate, which I'll show you here in a second. But the whole idea is I'm using a really big tool because I think that the chips will be small, but there's going to be some slotting operations, and I need a large amount of room to clear the chip. So my theory is if I'm cutting a 1/2 inch wide slot, it's going to be easier to get a 2 or 3 thou thick chip out of that slot than if, say, it was an 1/8 inch slot. The idea is I'm going to use an air blast, and hopefully the air will be able to get in there and pull that chip out and keep it from melting and recutting against the tool. So we're going to do an outside profile. I'm going to do a separate last pass of 2 thou. So I'm going to leave 2 thou while it does the first cut, then it's going to come back around and do a thin shaving. That may or may not be necessary. I'm feeling like that's going to help with surface finish. We'll probably play a little bit around with the conventional incline milling. We're going to go 2600 deep, 260 thou deep to cut through. I want to make sure we add ramps to this toolpath and make sure it's a spiral. That's pretty much the gist of pretty much all the profile cuts, but that's going to be my inside cut for this stepper hole, and I'll probably put a screw and washer around this lip to hold this edge, because the stepper mounting screw holes are going to be kind of small and they're going to be drilled and tapped, and I want them in a precise location. So I just want to make sure when I profile the outside that this part doesn't doesn't fly up because it is kind of it's a, what do they call it, a right hand end mill. It's an upcut basically. So it could potentially pull up the part. So I'm on it when it cuts it free. So what I want to do is hold it down. So I'll probably just put a screw in there and a washer to hold it down once this stepper hole is cut. Anywho, we're going to calculate this tool path now. We're going to call this stepper hole. And we're going to calculate, and it's going to yell at me because I'm going 260 on a 250 part. Yes, we want to go through. Alright, so now that part, that tool path is done. It's probably going to leave a puck in the middle, and I'm pretty sure between the large diameter rod of the end mill and the large diameter of the hole we're cutting, there should be enough room in there with the air blast to push it free. Hopefully it doesn't jam in there. I don't think it will once it's cut free. So that's it for the inner geometry. The next thing we're going to do is do the outer profile. Alright, so we got the last bit is to cut the outside profile, which will cut this part free from the workpiece. So that's going to be another profile tool path with this vector as its geometry. We're going to cut 260 thou deep again, using the same aluminum end mill. This time it's an outside cut. And again, we'll probably play with the climb and conventional. I'm going to start with conventional, but we'll see how that goes. And then we'll do the separate last pass again. We'll leave 2 thou. And we'll also add ramps, make sure it's a spiral. And we'll play with these feeds and speeds a bit, but you get kind of the idea. This will be the outside. And we'll calculate that. It's going to yell at me about 260. Yes. And alright, so we have defined all of our tool paths. And so the process of this will be first will be mount the workpiece using whatever means we need to do. Even if it'll overlap the parts, it's fine, because we're just going to make sure we don't interfere with the holes that we're going to be using. Then we're going to come back and put in the V carving bit and just pop these little holes. Once those are in place, I will stop and drill out a couple of holes. I might actually just do the stepper hole as well, because these two paths don't need any interior work holding. It's only before we do the outside. So I'll play around with that process a bit, but then we'll do this conventionally. Then we'll cut this inner stepper hole, and then once we've got the workpiece secured and fastened down, then we can go ahead and do the outside tool path to cut the part free from the workpiece. Let's do a real quick preview of that. Alright, and then let's preview that real quick. So it's really tough to see, but there are little tiny pock marks there, and so that's covered. Then we'll probably go ahead and do the stepper hole while we're at it, and we'll let that run. That didn't go through. Oh, it did go through. We'll let that run, and you'll see this little puck gets left behind. Hopefully it'll be blown clear. Now I can go and I'll probably drill these 2 holes out and put a hole here and screw down the workpiece. Then the next thing we can do is the profile tool path, and we can run that, and that'll free the part, and this will be what's left of our outside piece, and we can just hopefully that'll go away. And as you see here, we've basically got our piece ready to go. Then we'll take it off the machine and deburr it and whatnot. But cool. So the preview confirms that we're good to go there. It's all going to work out well. We're going to set these up as separate files. First of all, because they use different tools. I'm actually kind of curious now. Let's see how long everything's going to take. 22 minutes for the outside cut. Yeah, so I'm kind of watching that speed a little bit. I might tweak those things just a tad to get the cut speed faster if the machine can take it. I'm also going to play with the feed rate override in some places, but you know, I've got a lot of options. We're going to see how well I can do it. So the next bit, all we have to do now is save these toolpaths. Alright, so to save the toolpaths, we're going to choose which holes we're going to cut. And in this case, it's just going to be the drilling bit with the V carving. See, we've got the V bit. So we can just say this. I'm going to number these. I just do this out of habit so that they are sorted in the order that I want to run them. So we'll just do the stepper hole now. We'll do a 2 in front of that. And then we'll do, this is where we'll screw stuff down. And then number 3, we'll do the profile for the outside. And that's it. Let's let's take that G-code over to the machine and get stuff cutting. Okay, so as described, I'm going to put this piece of MDF down as kind of my spoil board for this, because I don't want to cut into the machine bed for cutting aluminum for these parts. So what I'm going to do is have this 3/4 thing. I'm going to screw it down, so I'm really only cutting into this with some screw holes. Fairly minor, low impact sort of thing. And then we'll use the machine to figure out some locating stuff to get fixtured onto this part. This also allows me to keep the vise in place so that if I do get orders in the middle of this build, I can still make some irons. But all of the parts will get cut on this surface here. The upside of having a bigger machine is I can have it set up for multiple things. So that's what we're going to do. I'm going to go grab the drill and get some screws and put this down onto the machine rope. So what I'm going to do is I'm going to flatten an area on here that's 20 inches square. The board is 22.5 by 23, so somewhere roughly in the middle is fine. This is going to make a hell of a mess, but I'm going to put the air cleaner on and my dust masks, and I'm probably going to spare you the cutting operation. I might pause it. I might show you the start, but it's going to make such a damn mess that I'm just going to put the air breather on and probably not film it. You may or may not get a little footage here. We'll see. Good Lord, this is going to be messy. So we're going to get started. Alright, well that absolutely sucked, but it's now flat enough to do the job, and I don't actually have to do any locating stuff because I've got this little ridge right here that I can use to locate against, and the whole idea is I wanted a line that was parallel with the y-axis so that I can hold the part, the workpiece in place while I do some machining on it. So that saves me a lot of finagling. And I just have this nice long line I can butt everything up against this location. So what I'm going to do is I'm just going to locate a part here. This is 1/4 inch material that I'm going to use to make one of the stepper mounts with. That'll be one of my first parts. This will be the first part on this build. And the reason I've chosen this is because if I screw this piece up, I have 4 or 5 more of this same material, so this will help me perfect cutting aluminum. This machine is not very rigid, and cutting aluminum is asking for trouble. I've never had really good success cutting aluminum. I think there were some parts when I cut for the guitar fret slotting rig where it was some aluminum pieces on the sides, and those just had some really chowdered up edges. So we're going to try some new stuff. I talked about that in the cam area where we're going to use 1/2 inch tooling for cutting the profiles, figuring one, my 1/2 inch tooling is better suited from a fluting standpoint, bigger gullets that are smoother, so the chip evacuation should be better. That's my basic reasoning on that. And rather than cutting out holes or anything like that, I'm only going to mark with a center point. using a V-bit. You saw that while I described that. So the first thing I need to do is hold it down while I cut the V slot, the V poking. Basically, I'm just going to locate the V, using the V-bit. I will locate the holes and then use those as starting points in either the drill press or right here on the machine to drill a couple of holes. I think I'm going to leave it on the machine to drill a few holes. Yeah, I will leave it on the machine. I'll drill a couple of holes to mount to hold the workpiece down. So then I'll have outside edge holding and inside part holding, so that when I do cut the profile out, I can cut all the way through and free the part without the part flying all over hell. So that is where we're going back down to the machine again. I'll start cutting, or I'll start mounting that workpiece down to the machine now. Alright, so I'm just going to try. I think I'll be able to just drill a pilot hole right there, and then use that as my fastener location. Yeah, that'll do. Just screw this down. This may or may not work. We'll see. Start the screw first. Oh yeah, that'll work. Okay, so now I've got my part against this edge that I cut. I might make that a little more positive, but it's working so far. So there, that's holding that edge down. I'm going to need some on this side as well. I actually should have done it on that side first. What was I thinking? Yeah, we'll do one over here. I'm going to want it. So one of the things I'm struggling with is that, you know what, I'm just going to do them far enough away to put a washer on it, because I want to be able to control the tension. So we're just going to pop a couple of holes right there, a few holes, because then I can put a couple of washers in it. Oops, just push that away, get all that out of the way, and using the washers I can put the tension down. So this don't make no sense, does it? So I want to push up against this edge, which is fine, and then I'm going to grab behind me in a magical drawer here somewhere. Where are they? Are they in there? Looking for my Fiender washers. These might be too small. Yeah, that'll do. Alright. So then I can take these, and they can hold, and they'll hold. I'll have to take one of these out at some point, but I'll have to take, oop, wrong drill. I have to take this one out, in fact. Okay, so this is not the greatest of work holding, but for this actual task, I'm going to put that in last. Okay, so now we have enough gap. There we go. All right, we can do this. We can do this. Put this one in here. So I'm also in my own head. In my head, I'm visualizing where the part that I'm going to be cutting out of this is going to be located, because that'll help to ensure that it's where it goes. I think I'm going to grab a screwdriver by hand after I'm going to start all these threads, and then I'll finesse the part in. So the reason I'm not doing anything super permanent is because I'm literally cutting one or two parts, and I really don't need a sophisticated fixturing system here. I just need some level of work holding that will keep it from sliding on me. So that's all I'm going to do, is I'm going to get all this stuff started. I'll just start them now. Get all these started. And all I'm really concerned about is being careful that I get the part registered against that line, that ridge. So let's get one more, and because of that, once I've done that, we'll well, ow, pinch your finger. Okay, so I'm gonna go grab a hand screwdriver. I'll be right back. Okay, so now we'll give a little bit of room here for these guys to move around, and we'll just ensure that it sits nice against that, and then tighten these first. These aren't super loose so that it doesn't push that away, but it doesn't let it rise. Okay, there we are. Now our part is well secured. Like so. Like so. And parallel. So, frankly, I don't have to even be this careful because I make much more allowance for it being misaligned in the cam anyway. But it's not a bad exercise. Okay, that isn't going anywhere. That's good. Move these. All right. Yeah, it's not going anywhere. It's held down really good. Okay, good. Whew! A lot of work there, huh? All right. Next task is, oh shoot. The next task is to undo this screw because the, actually, you know what? I'm gonna reset this one. This one's fine. So the reason I was doing that is in the cam, you'll remember I chose this lower left corner as my origin, or I should say I chose a corner as my origin. That origin would have been this lower left corner. What I can do actually is loosen, 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 and drag it this way. There. So my left and rights are there. That'll let me origin off that corner now. Tighten, 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 and a tighten. That'll give me my XY origin. That's fine. We're still good? We are still quite good. Okay. Poof! Part mounted. Alright. The next thing I will do is it's cutter change moment here. We're gonna bring my axis up here and bring it over to myself so it's easier to do. And I think we're gonna use, I hate to use that particular one. This one is my branding iron one, so I think I'm gonna grab a different one. I'm gonna grab one of the backups, one of my carbide tip ones that'll work beautifully for this task. Yeah, this will work just fine right here. Need me a 1/4 inch collet. Yeah. And we'll do that. So I'm gonna get this cut in. This might all be boring footage, but hey, what the heck. Put this on here. Okay. Now, I should be able to, I don't need this to be beautiful. Remember, so I should really point out, I am not using this as a precision device in a lot of respects. In a lot of areas, this is not high precision for me. There is some. So locating these holes is a precision thing. But I don't need to locate it within the part too terribly well. Like, it doesn't matter if I'm off a 1/4 inch even. Like, in this part, the part is way oversized. The workpiece is, anyway. Okay, so that's going to be my X and Y zero. So this corner is my X and Y zero. I'm going to come in and just around this area, I'm going to zero my Z axis here. Oop, I lost a cutter here. Hold on. Zero my Z now. Again, this is also a non-precision thing. I'm not using this as a precise device from a Z axis even. I just need it to be able to cut. Okay, so this is ready. The part is located. I'm going to grab the G code for this that's going to cut one of the stepper mounts, or not cut the stepper mount, but it'll locate the holes that the stepper mounts will be used, that will be used for the stepper holes. The stepper mount. Jeez. This is cut 1. This is operation 1 for the stepper mount, which is just locating all the holes that are going to be drilled in it later. This should go fairly smoothly without much trouble, and then I can bolt it down. I'm going to be very careful figuring out. I may bolt this to the machine too to get a better sense. We'll see. So yeah, let's go get the G-code and I'll bring you back here in just a second. Okay, here we go. Ceremonial first cut first part of the new CNC machine. Here goes. This should be fairly small, very simple thing. It should take 7 seconds according to VTAR Pro or Aspire. So this is just spotting where I'm going to put some holes. So this should go really quickly. Very low impact, shouldn't be a problem. Ready, set, go. There it is. Alright, so that was fast. However, nowhere near deep enough on the holes. I can't even tell those were the ones. So I'm going to drop the spindle another 10 thou and run it again. Ready, set, I'll go. Yeah. There it is. That's actually doing something. That'll do. That'll mark those holes. So let's get over here. I'm not sure if you'll be able to see those holes, but they are definitely marked now. So what I'm going to do next is these two outer holes will hold the part, so I'm going to drill them. That's through. And this one. So this is because I don't think I can make the holes the right size I need here. And through. Okay. Those are the first couple of holes. I'm going to try not to need more. I'm feeling these are going to get there though. We'll see. Alright. So now I think I need to go a little bigger because I want to put some screws in there, and they're going to need to be bigger holes than that is, but they need to be just big enough. So I'm going to measure this and get the right size hole. Okay, so we've got an 11/64 bit, which is just big enough to pass those threads. Commit to that hole. Okay. Then this should be able to go in. Now my hope is that the head, oh yeah, perfect. My hope is that the head of that screw is still smaller than the boundary layer of the part I'm putting in here. And I think it is. There we go. One more screw. Where did I put the screws? Screws are over here. And what this is going to do, along with another op here in just a sec, is hold the inner piece, the part that I'm actually making, safe so that it doesn't flop around when it's been cut free. So the next step, this will be the part that's a little strange, is we're going to change out this cutter for a bigger bit for the cutting it out part. We're going to cut the stepper hole. Hold on a second. Alright, so we've got a comically long 1/2 inch end mill here, but it's the only thing I've got that I think will work. So the only thing I need to do here is my X and Y are fine. I need to zero my Z out. So I'm just going to do the same thing I did on that for the V carver. Should be close soon. There it is. Okay, felt it just ticking, so yep, that's perfect. That's Z0 right there. Now this first op is to cut out the hole for the stepper. There's a ring on the stepper. I should actually, because there's, no, they're the same size for me. Okay. So this will cut out the ring on the stepper. I'm going to drop that speed all the way. I'm hoping that I don't have to speed the router up, but we'll see. This could work, or this could fail entirely. This is a case of my machine is not that rigid, and therefore may completely fail at this. We don't know for sure. I'm going to take a gamble. I'm going to put on hearing protection and eye protection, because this is going to fling some chips around. And yeah, we'll see what happens. I'll bring you back when I'm ready to start cutting. I'm going to take a little nervous moment here first. Well, I didn't die. The part didn't go anywhere. These are all very positive things. And the surface finish on that isn't bad. I can live with it. All right, cool. I am emboldened by my success. So the 1/2-inch cutter, yeah, it was noisy and it had some chattering, but the cutting parameters, I babied it quite a bit. I moved it like 20, I think, inches per minute. There's a bit of heat in her. Cutter's fine. The shavings are not incredibly fluffy. I played around with the speed, with the spindle speed a bit. I had it all the way down, but that felt a little chattery, so I kept toying with a speed, and it I don't know, it held up beautifully. So I am emboldened by my success. So what I'm going to do now, the next step is to cut it out. But first, what I want to do real quick is throw in a brace on here. Maybe I'll just drill a hole and put a washer for a screw here, because I want to make sure the middle bit does not come out. So I'm going to grab the drill bit I need. I put the drill bit away like an idiot. So I'm going to grab the drill bit I need, and I'm going to put a washer and a screw in the center of this hole, just to help keep that part in place. I'll be right back. All right, got our extra screw down in there now. We'll zoom you in here a bit. Oh, I forgot the focus was screwed up, sorry. Yeah, let me get you in there a bit better. Hold on, working on it. There we go, focus. Okay, we're gonna do it like this. The next step, now that this is held down pretty good, is to cut out the outline. So that's the next thing. I'm gonna take that on right now, and well, I guess here we go. I'm gonna stop the mic for a bit, go for some, well, yeah, let's get the new G card, and here we go. Alright, wow. So there was a good bit of recutting happening over here. So my surface finish isn't great, but I'm not upset. That final pass kind of cleaned most of the recutting. So it got warm. It got pretty warm. So that was one of the things I was most concerned about, was heat. So what I'm going to do is, I didn't have air over here to blow on the tool while it's cutting. I'm going to try to get some kind of air set up. But right now, what we have here is a part that I was aiming for. Now, I know there's a lot of waste. Hey, you know what? I'm going to leave this pretty much as is, because I have another part just like this I want to cut. And now that I know that I can, I will be ready by just leaving these screws slightly loose to remove that part. Yeah, that'll come out at some way. Okay, there you go. That'll come out. Get this out of there. Our part came out really pretty well. So there's a couple of things I'm going to have to do to this after now that this is done. Is we've got to drill the 4 spindle or the 4 stepper mounting holes, and these holes will get turned into slots. But I'm going to do that on the milling machine because, one, I don't trust the rigidity of my machine to cut those slots with an 1/8 inch bit, which is what I would need. But this is pretty damn good for, I mean, granted I will tell you, this surface is kind of crappy. I don't know if you'll be able to see it very well. This edge finish is terrible. But for a machine not designed for this act in the first place, I'm going to be fine with this surface finish. I need to deburr. They're pretty sharp edges. But in the end, I got one part, and I will have one more just like it, where I can drill these stepper holes. I'm going to take this over to a stepper real quick, or bring a stepper to it, and confirm that it slides into this nicely, and I'll be able to check where my little holes went to make sure they're going to go where I want them to, or they'll be useful in their positions. And I'll be right back. Alright, really quickly, we've got ourselves a stepper. This is that little shoulder I was telling you about here. And doink! She fits right the heck on there. And you won't be able to see it right now, but when I mount it, when I drill the holes for it, you'll see the center points are exactly where they need to be for this stepper. And that, my friends, is that on that end. I am quite pleased. This is super working. Cool. I got one more just like this to cut out, and then a third one, which is a flat square that'll be on the this way axis, the x-axis. So, cool. Step 1, part 1, almost done. I got to go drill a couple of holes, and I think I'll do that quick so I can check the threading too, because I got to tap these holes. These have to be threaded. Yeah, but hey, pretty good so far. I'm gonna cut the second one real quick as well, I think, or something like that. But yeah, first part, success. Not great surface finish. This milling is terrible, but I didn't have to make this part by hand, so perfect. I'll take it. All right, I'll bring you back when I'm ready for whatever the next step is.